Hello, everyone. Good evening. Good evening. Nice to have you on the live class. Today we'll be looking at polygons. Polygons. Okay. And we'll be starting in a few minutes. We'll be starting in 1 minute actually. Let me just invite my students from the WhatsApp group to join the class. So we're almost ready. Okay, so today we are looking at polygons. So we are continuing with our lesson on angles, triangles, and polygons. Okay, so let's start. So we are continuing with our lesson on angles, triangles, and polygons. That's what we are looking at today. So the first thing we need to look at is what is a polygon? That's the first thing we need to look at. What is a polygon? So for us to understand the topic, we must first of all understand what a polygon is. So a polygon is a 2D shape or a plane shape. Hello, Marcia. Good evening. Nice to have you in the class. Welcome, welcome, welcome. Please, if you are joining from the WhatsApp group, please, I'd like to uh, know who is here. So Marcia is here. Confidence is here. Francis is here. Francis, is this your first time? Were you here in the previous class? So we are looking at polygon. Okay. So a polygon is 2D shape that has at least 3 sides. Benedict, are you from the WhatsApp group? A polygon is a 2D shape that has at least 3 sides. Two-dimensional shape or plane shape that has at least 3 sides. Okay, so whenever you see a plane shape that has at least 3 sides, that plane shape can be called a polygon. Faith, good evening. Are you from the WhatsApp group? Felix, are you from the WhatsApp group? Okay, so when a 2D shape has at least 3 sides, then that 2D shape is called a polygon. So the first thing we're going to do is we're going to see the different types of polygon and how many sides they have. So types of polygon. The first type of polygon is a triangle. So a triangle is a polygon that has 3 sides and 3 angles. So 3 sides, 3 angles. So that's the smallest type of polygon. Doris, nice to see you. Good evening. Anastasia, nice to see you. So a triangle is a 2D shape that is a 2D shape or a polygon that has 3 sides and 3 angles. Next is a quadrilateral. So a quadrilateral is any polygon that has 4 sides and 4 angles. A quadrilateral is a polygon that has 4 sides and 4 angles. The next we're going to consider is a pentagon. A pentagon is a polygon that has 5 sides and 5 angles. Please, if you are joining from the WhatsApp group and this is your first time or you've been here before, just indicate by letting me know that you're in the class so that I can take down your name as attendance. So pentagon has 5 sides, 5 angles. The next is number 4, which has Daniel Van Dyke. Nice to see you. Which has a hexagon, sorry. A hexagon has 6 sides, 6 angles. So this is just an introduction actually. So you need to know a little bit about the topic before we start solving questions. And then 5, we have heptagon. A heptagon has 7 sides, 7 angles. We have octagon. An octagon has 8 sides, 8 angles. So what I would like you guys to do, if you've not seen these different shapes before, so that we don't spend more times in the introduction, at the end of the class, just go back to Google and look for pictures of these different shapes so I can have a view of them, okay? So if I begin to draw each of them, it will make the class longer than necessary, okay? So we've looked at the first 6: triangle, quadrilateral, pentagon, hexagon, heptagon, and octagon. The remaining 2 we're going to look at is humble, good evening, nice to see you. I'm going to wipe here off. So the remaining 2 we have are nonagon with 9 sides, 9 angles. Nine sides and 9 angles. And then we have number 8, decagon with 10 sides and 10 angles. Okay, so these are the Eniola, good evening. Are you from the WhatsApp group? Okay, so these are the different types of polygons. Okay, now we want to look at the sum of angles in a polygon. Okay, nice to know that. So we want to look at the sum of angles in a polygon. So let's use a quadrilateral as an example. Remember, a quadrilateral is a polygon that has 4 sides. So if this is a quadrilateral, it has angle here, angle here, angle here, and angle here. Now, the next thing we're going to look at is sum of angles in a polygon. So in each of the different types of polygons, how do we find the sum of angles in those polygons? Okay, so that's what we're going to be looking at, sum of angles in a polygon. So whenever you are told to find the sum of angles in a polygon, there is a formula you can apply to find the sum of angles in a polygon. And that formula is n minus 2 times 180 degrees. So if you are told to find the sum of angles in a polygon, whatever the polygon is, whether it's a hexagon, an octagon, a quadrilateral, whatever type of polygon you are told to find the sum of angles, this is the formula you are going to use. So I'm going to solve 3 of the 8 polygons we've considered. I'm going to solve the sum of angles in a triangle, sum of angles in a pentagon, and sum of angles in an octagon. Then you guys will do the rest. Okay, so now let's look at sum of angles in a triangle. In our previous class, we've already learned that sum of angles in a triangle is equal to 180 degrees. We've already learned that. So we're going to use this formula to confirm what we have already learned. So let's see the sum of angles in a triangle using this formula. The formula is n minus 2 times 180 degrees. N represents the number of sides of that particular polygon. So from what we've learned, what will be the value of n for a triangle? Cecilia, nice to see you. Nice to see you. Welcome. From what we've learned, what's the sum of angles? Sorry, what's going to be the value for n for a triangle? 3. So Daniel has 1 mark from today's class. Remember, in each class, we have winners that we are going to select. Oh, Marcia said 180. No, I was asking about the value of n, which is the number of sides. So for a triangle, the n is equal to 3. Okay, n is equal to 3. So we're going to fix this into this formula. So this will give us 3 minus 2 times 180 degrees. 3 minus 2 is going to give us 1. So when you multiply by 180 degrees, that will give us 180 degrees. So this confirms what we have already learned from our previous class, that sum of angles in a triangle is equal to 180 degrees. So this formula can be used to calculate the sum of angles in any polygon. Okay. So we've seen the sum of angles in a triangle. The next one we're going to consider is sum of angles in a. We've learned about quadrilateral, so we're going to confirm with this formula. Because if I just ask you what's the sum of angles in a quadrilateral, somebody is just going to give me 360 degrees because we have already learned that. Okay, so let's look at sum of angles in a quadrilateral. In a quadrilateral. So how many sides does a quadrilateral have? Or what's going to be the value of n for a quadrilateral? What's going to be the value of n for a quadrilateral? Marcia came first this time. Very good. Marcia has 2 marks. Marcia, I'm thinking of sending you one of my branded t-shirts. I don't know how I'm going to get it to you. Maybe we'll discuss about that later. Okay, so the number of sides of a quadrilateral is 4 sides. So all we need to do is, we know that our n is equal to 4. So for a quadrilateral, we're going to have n minus 2 times 180 degrees. N is equal to 4. So 4 minus 2 times 180 degrees. 4 minus 2 gives us 2. So we have 2 times 180 degrees. And just as we have learned from our previous class, sum of angles in a quadrilateral is equal to 360 degrees. So this confirms what we have already learned. This confirms what we have already learned. So next, you guys should find the sum of angles in a sum of angles in a hexagon. Sum of angles in a hexagon. Fastest person to get the answer, 3 marks. These ones will be 3 marks. No, 3 marks is too much, 2 marks. Sum of angles in a hexagon. 720 degrees. No, not the sides, not the number of sides. The sum of angles. That means you need to apply this formula and get the sum of angles. Sum of angles in a hexagon. Somebody said, but Daniel said 720 degrees. So let's see if somebody else can get that. Sum of angles in a hexagon. Sum of angles in a hexagon. That's number of sides, Doris. That's number of sides. $720, okay? Confidence also says 720. 720. Good. So all you need to do is put 6 here. 6 minus 2 gives you 4. 4 times 180 gives you 720, correct? The next, sum of angles in an octagon. So Daniel has 2 more marks. Sum of angles in an octagon. I'm seeing Tim. Is that your name, Tim? Are you from the WhatsApp group? And Richmond, are you from the WhatsApp group? Good evening. Are you guys from the WhatsApp group? Sum of angles. Okay. Daniel has gotten 1080. Confidence also said 1080. Success, nice to see you today. Marcia, 1440. And for an octagon, check again. Benedict say 1080. Okay. Please, those of you that are joining the class for the first time, after the live class, please contact me on WhatsApp so I can add your name to the list. Okay, so we are looking at octagon. Octagon is 8 sides, so n is going to be 8. 8 minus 2 is going to give us 6. 6 times 1000, 6 times 180 is going to give us 1080. That should be the correct answer. Okay, very good. So we've seen what a polygon is, we've seen the types of polygon, and we've seen how to calculate sum of angles in a polygon. Okay, but now we are going to also classify polygon based on 2 criteria. We're going to look at regular polygons and irregular polygons. Regular polygons and irregular polygons. Regular and irregular polygon. Okay, thank you, team. Dominic, nice to see you. Comfort. So regular and irregular polygon. Now polygons can be classified as either regular polygons or irregular polygons. A regular polygon is a polygon that has equal length of sides and equal size of angles. A regular polygon is a polygon that has equal length of sides and equal size of angles. Okay, so a regular polygon is a polygon that has equal length of sides. That means all the sides have equal length, and also all its angles have equal size. So whatever the size of one angle is, that's what the size of all the other angles will be. Okay, whatever the size of one length will be, whatever the length of one side, that's the same length for all the other sides. So whenever a polygon is like that, that polygon is called a regular polygon. So if we have a polygon in this form, as an example, now we know that this is a square. Of course, this is a square, but apart from being a square, it is a regular polygon because we can see that all the sides of this polygon has equal length. Also, the angles are the same, 90 degrees, 90 degrees, 90 degrees, 90 degrees. So since this shape, remember a square, has equal length of sides and equal size of angles, this can be called a regular polygon. But on the other hand, if you have now, this shape cannot be considered a regular polygon. Although all the angles have the same size, 90 degrees each, but because the length of the sides are not the same, you cannot call this a regular polygon. That means a rectangle is not a regular polygon, but a square is a regular polygon. So a regular polygon is a polygon that has equal length of sides and equal size of angles. Okay. So from what we've said, can you picture, let's use one type of polygon, a trapezium. A trapezium. A trapezium looks like this. Now, will you say this is a regular polygon or an irregular polygon? Will you say this is a regular polygon? Though we've not talked about regular polygon. Is this a regular polygon? Is this a regular polygon? Okay. It's not a regular polygon because it's obvious that the length of the sides are not the same and then the angles are not the same. So a regular polygon has equal length of sides and equal size of angles. Irregular polygon. An irregular polygon is a polygon So an irregular polygon is a polygon with sides and angles that are not equal. So once at least one side or one angle is not equal, that is an irregular polygon. So once at least one side is not equal, it is an irregular polygon. For it to be a regular polygon, all the sides and all the angles must be equal. Once one of the sides or one of the angles fails these criteria, then it is classified as an irregular polygon. Are you there? Sorry, call came into one of my phones. Is the network back? Is the internet connection back? If you guys can hear me, please indicate. If the internet connection is back, please indicate. Okay, good. Thank you. So the next thing we're going to do is we're going to look at how to calculate the size of each angle of a regular polygon. So if you have, what shape is this? Can you guys tell me what shape is this? What type of polygon is this? Pentagon, correct. So since it has 5 sides and 5 angles, it is a pentagon. Okay, good. So now, this pentagon, let's assume it is a regular polygon. That means all the sides and all the angles are equal. How do I know what these angles are? How do I know what they are? So that's what we're going to do now. How to calculate the size of each angle of a regular polygon. Okay. So the reason we are trying to do that is because we know that all the angles are the same. So once we know what the size of one angle is, we know what the size of all the other angles are. Okay. So let's see the formula we're going to use. The formula is to calculate the size of each angle of a regular polygon. We're going to use n minus 2 times 180 degrees all over n. So that's the formula. So this is the formula we're going to use to calculate the size of each of the angles of a regular polygon. Now we are going to try to calculate the size of a regular triangle. A regular triangle. So for a triangle, n is equal to 3. So we want to calculate the size of each angle of a regular triangle. Now I want to ask you a question. What is another name for a regular triangle? We learned the different types of triangles. What can you tell? What would you say the name of a regular triangle is? Of all the triangles that we've learned, which of them is also a regular triangle? This question comes with 3 marks. Which of the triangles that we learned about in our previous class can be considered a regular triangle? Let's see if anybody can get the answer. For 3 marks. Equilateral triangle. Okay. Just that thing, you are not part of the WhatsApp group. Equilateral triangle. Okay, that's correct. Benedict. I'm going to give Benedict the marks because I think Benedict is part of the WhatsApp group. Have I written his name down? Thank God you answered because I've not written your name down. No, no problem. Benedict. Equilateral triangle, correct. Okay. So the reason is an equilateral triangle has all its sides equal and all its angles equal. So since an equilateral triangle has all its sides and all its angles equal, you can also call it a regular polygon. Okay. So we know that n is equal to 3. So we can simply say 3 minus 2 times 180 degrees all over 3, which gives us 3 minus 1. Seems the network is bad. 3 minus 1 gives you 1. 1 times 3 minus 2 gives you 1. 1 times 180 gives you 180. So we have 180 over 3, which is 60 degrees. Okay, that shows you that each of the angles of a regular triangle is equal to 60 degrees. So with this in mind, what will be the size of each angle of a nonagon? The size of each angle of a nonagon. Okay, you can see very clear. The size of each angle of a nonagon. 2 marks for that. The size of each angle of a nonagon. (140 degrees). Okay, I think it's going to be Van Dyke's Daniel's Day. I prefer to call you Daniel. Whenever I call you Van Dyke, I think of the footballer. So who else is confirming that it's 140 degrees for each of the angles of a nonagon? Okay, and Yola says 140 degrees. Okay, Cecilia says 60 degrees. We already got 60 degrees for triangle. We already got 60 degrees for a triangle. So if you put 9 here, you're going to get 9 minus 2, which is 7 times 180 degrees, then divided by 9. Or you can just do 7 times 20, which is 140 degrees, correct? So Daniel has more 2 marks. He's leading the pack, okay? So what will be the size of each angle of a regular decagon? Decagon. Size of each angle of a regular decagon. (144). Okay, 144. 144. Okay, everybody's saying 144. (144). Okay, so 144, correct. Good. So this is a simple way to calculate the size of each angle of a regular polygon. Remember, this is for a regular polygon. We cannot use this for, we cannot use this. Shidera, nice to see you. I was expecting to hear from you after our last class on Saturday. You were the winner of the cash gift, but you didn't contact me. Okay, so please contact me after the class. Just send me a message. Yourself and the person that is going to win today's class. I don't know who is going to be the winner yet, but I only know that uh, Daniel is leading the class. Okay, so now we've seen what a polygon is, we've seen the types of polygon, we've seen how to classify polygons based on regular polygons and irregular polygons. We've also looked at how to find the size of each angle of a regular polygon. But for an irregular polygon, someone said the network is bad. But for an irregular polygon, the sides are not the same, the angle are not the same. But we can calculate the size of a missing angle of an irregular polygon. We can calculate the size of a missing angle of an irregular polygon. So that's what we're going to do next. How to calculate the size of a missing angle of an irregular polygon. Remember, an irregular polygon does not have equal number of sides and equal number of angles. So how to calculate a missing angle of an irregular polygon. So for you to do that, first you must always remember the sum of angles of that polygon. You must know the sum of angles of that polygon. So let's look at an example. Okay. So I just, and your lie is still saying that the network is bad. Is it just from herself or from everybody? Let me confirm, please. Is the network bad for her alone or for every other person? Please let me know if the network is bad for everybody. Because on this phone that I'm using, this one in front of me, the network is okay. Or the network seems to be okay. 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 So now we're expected to find the value of x in this polygon we have here. So whenever you're given, okay, good. So whenever you're given a question like this and you're expected to calculate a missing angle, the first thing you need to do is identify the polygon you are working with. So first, what polygon do we have here? What polygon do we have here? World Daily Muslims, are you part of the WhatsApp group? So what type of polygon do we have here? First thing, that's the first thing we need to know. The type of polygon we are working with. Pentagon, good. So it's a pentagon. It's a pentagon because it has 5 sides and 5 angles. That's the first thing. Then the next thing we're going to ask ourselves is, what is the sum of angles in a pentagon? So now we've identified that it's a pentagon. The next is, what is the sum of angles in a pentagon? If you are solving a question and you cannot remember the exact value, it's better for you to use the formula immediately. So the formula is n minus 2 times 180 degrees. And so since it is a pentagon, 5 sides, we have 5 minus 2, which is 3 times 180 degrees, which gives you 540 degrees. So the sum of angles is equal to 540 degrees. So that's the first thing you need to identify. What is the sum of all these angles in this pentagon? If you miss that, then you get the wrong answer. So the next thing we're going to do is we are going to add all of them and equate them to 540 degrees. So this will give us x plus 103 degrees plus 108 degrees plus 93 degrees plus 130 degrees. Let me see where it's going to get to. Okay, equal to 540 degrees. Okay. So when you add all these values, what will you get? When you add all these values, 103 plus 105 plus 93 plus 130, 434. Can someone else confirm it? 434. So we have x plus 434 degrees is equal to 540 degrees. X is equal to 540 degrees minus 434 degrees. X is equal to 106, right? 106 degrees. So that gives us the value of x. So you get questions like this. In most situations, you get questions like this when it is an irregular polygon. When it's an irregular polygon. So just give me a minute. While some persons are writing this, just give me a minute. Let me get some questions. Okay, so let's try another question. I'm going to write it down on the board. We are almost done for today. Okay. Okay, so let's solve this question. This will be our last example for today. So we're expected to find the value of x in this question. So just because of space and also time, I don't want to use a more complex uh, polygon. So we can see that this polygon is a pentagon. It has 5 sides. So we already know that the sum of angles in a pentagon is 540 degrees. So we don't need to calculate that again. All we need to do is sum all these angles within this pentagon and equate them to 540 degrees. So let's do that. So this will give us 5x plus 2 plus 3x plus 5 plus 8x plus 8 plus 4x plus 15 plus 5x plus 10 is equal to 540 degrees. Okay. So let's add all the values with x. 5x plus 3x gives us 8x, plus 8x gives us 16x, plus 4x gives us 20x, plus 5x gives us 25x. So we have 25x. 2 plus 5 gives us 7, plus 8 gives us 15, plus 15 gives us 30, plus 10 gives us 40. So we have plus 40 is equal to 540 degrees. Okay, some persons have gotten the answer. Very good. So 25x is equal to 540 degrees minus 40 degrees. 25x is equal to 500 degrees. So when you divide both sides by 25, very good. So 25 can cancel 25, we have x is equal to 20 degrees. So that gives us the value of x in this particular question. Okay. So with that, I'm just going to write a classwork, and then that will bring us to the end of today's class. So on Wednesday, we're going to look at, we're still going to continue with polygons. We will look at questions that include other principles that we have learned, like sum of angles on a straight line, and all that. We're going to combine it with what we have learned today and generate some questions. Then we'll also look at how to calculate the number of diagonals in a polygon and the number of triangles that can be found in a polygon. Okay, so try out this question and then we'll be done for today. So this question carries 5 marks. Let's see. We are still going to use a pentagon for quick calculation. So this drawing is not drawn accurately, but you can just use it as a guide. Okay, so find the value of x in this question. Find the value of x in this question. My phone is almost going off, so that's one of the reasons we need to end the class. Find the value of x for 5 marks. So the persons who were part of the class that I have their names here is Marcia, Confidence, Francis, Benedict, Edith, Faith, Felix, Doris, Anastasia, Daniel, Humble, Eniola, Richmond, Success, Cecilia, Comfort, and Chidera. These are the persons whose names are on the list for today's class. If you were part of the class and you didn't hear your name, please let me know, because it's expected that if you're just joining us for the first time today, please contact me on WhatsApp so that I'm going to add your name to the list of students I have. Because at the end of the day, once we get to the end of the month, 156.5, that's the value of x. Okay, that's what Chidera said. 156.5. I hope you are not so much in a hurry. 156.5. It looks so large. It seems to be so large. I don't know if you're wrong, but it seems to be large. Don't forget, we have some minus signs here, which will be very important. 125, Humble. 115, Daniel. Okay, thank you.